All right, getting started on this SL amps. Well, not starting, but getting ready to finish it up. I already talked about the new IC receptacle, new HT fuse in place here. Well, I haven't wired it up, but the same that matches the original, which is no longer in use. That was switching the HT center tap to ground, and that matches the 4 I added for the output tubes. And I've gotten all the old components and old solder off this board that they used for the filters. And I have rebuilt everything except the new filter caps. This is the one remaining stock connection right here. The others, I got all the old solder and flux out and have put in the new dropping resistors and jumper wires for the bus for the ground. And everything is crimped. Nothing is soldered yet. The amp would actually work like this before solder is applied. That's very important to make sure that it's mechanically sound. I'll put the new capacitors in place, F&Ts like the originals, with some silicone, though I do think that the original application was a bit on the Kleenex side. I'll try to be a little more discreet. It's just personal preference. Electronically, it'll be the same. All right, much better. So, haven't soldered them all in place yet. I'm about to do some of them, and some of them I'll do to the wires that are in here waiting to go in. It's just a lot easier to do then. But everything is secure. Everything's got a mechanical connection before solder, and everything's got just enough silicone to hold it in place so that the stress of any vibration or is not on the junction of the leads and the cap body. The body is held to the board, and the leads are partially crimped around the eyelets, so it'll all be rock solid. I'll slightly straighten a few things up before I solder them and let the silicone set up. But this will be good as new, and that's the goal in this amp. Good as or better than new. All right, time to put it all together. So I ran the wire from the bridge to the new fuse holder, new wire from the fuse holder to this point, which is where the first stage filter cap comes in. And this is the wire that goes to the standby switch. See if I can fit that in that same hole. I may need to expose some new. Yeah, I got to expose some new wire on that. It won't fit with the solder. So just a small eyelet to get as many wires through as are necessary. Hopefully, all the wires that need to be shortened in this process here have just enough slack for me to do this. Sometimes just the diameter of the solder makes it difficult. If this doesn't work, I've got a backup plan. Let's do this one first. And of course, everything fights each other. Crimp that over on top so it's less likely to come loose while I do the next one. Arr. There we go. Crimp them both over together. Make sure that one's not coming loose. All right. We'll solder that. And then before we go any farther, I've got to redo the wire bundle that I disrupted. By removing the old wires. So let me get New cable ties, all handy. Pretty sure we're using the exact same cable ties. Zip ties, there's nothing too fancy about them. So I'll just replace them one at a time so I can keep the bundles where they used to be. I'll do one or two here, then I'll resume the video after I've got them all finished, because it's really not worth making the next 5 minutes all about this process. But just want to get in here and recreate where that was going. So when I'm done, it'd be really hard to tell that any work was done. There's one kind of hidden underneath here. Snip the excess off on those. And I'll catch up with you in just a moment when the rest are done. Okay, that's all nice and bundled up the way it was, including this little new run that goes over here. Now to do these connections, this wire here is to the, as I need to move my new wire out of the way, it's got a little bit more slack. This connection goes to the, this one's from the standby switch, and this one's to the choke. And again, I've got to get some fresh wire or they won't fit through that existing eyelet. Fortunately, they had enough slack to do that. The old ones went from the top. I think this will be prettier and I have a better chance of getting it reliable this way. I wish these eyelets were just a little bit bigger. But they turn out to be just big enough. All right, these three connections here won't be as tough because they only have a single connection at each thing it goes to. So this one is the screen connection. And then we've got the preamp connection. When I'm done, I'll get off any excess flux that might be present. I'll make sure that that one's all the way seated. Don't have a lot of slack on some of these. All right. And the reverb driver connection. Gotta get some of the old solder off. It's a little bit globbed. I don't know if you can see everything I'm doing. I just Can't take the time for cinematography today. All right, this one's a bit tricky to get to fit in the hole. That's what over obvious people said. All right, there we go. And again, these connections were done from the top originally. But I think it'll be prettier and just as reliable from the bottom. If I had a little more slack, I could have exposed some fresh lead and crimped them over like I did the first ones, but should be good. Now this board just mounts right back on these standoffs. And I've got the original hardware right here. So each one gets a tooth washer and a nut. The nut originally had some black paint on there. I think I've got something around here that'll do the same thing if necessary. I'm just going to put 2 on for right now, because they're really just there to keep things from vibrating. Let me find the right size nut tool for that. Looks like a 5.5 millimeter, which is not in my box, which means it must be one of my in-use ones. All right, 5.5 millimeter. I was correct. I think. All right, black paint is making it want to not turn. That's always a fun thing. So these may need to go into an acetone bath to make them really useful again. Let's see. Maybe I can just push on through. Yeah, I can just push on through. That old black paint will bow to my will. All right. Let me show you the next thing I've got to do before we can fire this up. All right, this is my temporary bias capacitor, which should no longer be necessary like this. I did this have 1,000 volts capability there because we were getting 700 volts before. So let me just temp in this ground connection. These should not be the final caps, and it's certainly not a ground connection that I would send out into the world. But this should allow me to power it up and test the voltage at the bias node, even if, and this is crucial, even if the HT fuse blows. Before, when the old HT fuse blew on the center tap, it sent one side of the HT supply crazy high, and this ended up at negative 700 volts. And that's why that old 500 volt cap failed. That's why I have 2 500 volts in a sloppy series connection for right now. So we're going to bring it up, measure what that voltage is with the HT all connected, and then we're going to disconnect the new HT fuse, which is no longer a center tap connection. It's right before this bank of caps between the diode bridge and this. And it should make this never go more negative than maybe 350, 400, which will be within the spec of the 500 volt cap we're going to put in there. So let me connect the speaker and power cable, and we'll get to that point. All right, we're going to power it on in standby, and we're having full power mode. And I've got on my light bulb limiter just in case something were to go wrong with one of the new caps, though I seriously doubt it. High quality components throughout the board, and I rebuilt it rather well, if I do say so myself. But anyway, right now, with the amp in standby, And with the light bulb limiter, all these voltages will be a little bit low. But right now we've got negative 415 volts at the negative supply. Take it out of standby. Got a brief surge in my bulb. That's normal for an amp of this current draw. And that goes down to 326, 328. That's good. So let me put it back in standby. And I'm going to disconnect the HT fuse that we just added. And see where that voltage is. It should still be about negative 400. Negative 415, 16. So even with the HT fuse blown, which is the failure mode that caused the entire problem with this amp to begin with, now with the change in the topology of how the fuse is done, we should be in a good position where this cap will not fail. Remember, that's in standby, and there's no current being drawn by any of the tubes that use that negative supply. And when the amp is out of standby, it's at negative 320-ish. All right, that's with the light bulb limiter. Let me turn off the current limiter. All right, negative 417. That's quite good. That's with the amp in play. Let me pull the HT fuse in that situation. Because if we're going to have a failure, I'd rather have it here on my bench than back when the owner is trying to use it at home. 430. So it's got a 15-volt swing now when there's no draw through the rest of the HT supply. So that should never approach 500 volts. Should max out about 430. And in normal use, should stay around 430. Now that is a very, very negative supply. At the bias point, that's actually negative 76, which means that at the cathodes, negative 75, at the grids, negative 75. That's with this bias trim pot that's in here now at its most negative. So that's a good place to be. This amp is going to be biased very cold right now. Most schematics show the grid's about negative 40 something. We'll play around with that. But like I said, I'm going to rebuild this entire output bias circuit to be both a little more rugged and to give a adjustability and to remove the externally adjustable bias pot, because in an amp this valuable, you don't want to have a, hey, what's this do knob. Even if there's not a knob on the pot, it is externally accessible and externally adjustable without a screwdriver. So it's not something you have to know what you're doing to mess with. But we have to do this first. Let me refamiliarize myself with the controls on the front. We'll make sure it makes sound. We've not heard this amp at all yet. All right, right before we hear it, I want to point out that I made a mistake. The active hot swapping that HT fuse blew it. That's a 500 milliamp fuse. We may be going up to a 750 milliamp, but with a new fuse. Everything is up. And the B plus is at 491, screen at 490, which is on the high side for 6L6s. We may talk about that. Let's see how it sounds. Probably be okay, but let me get the guitar connected and get the real mic set up. So if it sounds glorious, we'll hear that. If it sounds bad, we'll hear that as well in high def. All right, I'm rather pleased with this. It is the exact same circuit as the original, just laid out very differently. And doing this does two very important things. Number one, it gets the filter cap for the low voltage, the negative voltage supply away from the heat of the diodes and all that stuff, and that first dropping resistor that burned. And second of all, rather than having an externally adjustable bias pot, also known as the hey, what's this do pot, has an internally adjustable 22K. And with it just below noon, about 10:30, almost 11 o'clock on that position, the bias is now at 58.3 on one pair of tubes and 53.2 on the other. So given that these tubes suffered and that it's going to depend a little bit on the output of the 12BH7 cathode follower stage, which is right here, that's pretty much ideal. Just call it it's idling at 55%, which is a great place to be. And I look forward to doing a real playing test with this when I hook it up to the reverb tank and all that, and I figure out what all the things on the front panel do. But this is a really nice point to be at. Let me step back and show all the things we've done as a recap for those who haven't seen the other videos. All right, to recap, no pun intended. This amp had a big charred area over here where the original filter cap for the negative supply was mounted. And that's because when this HT center tap fuse blew, it meant one side of the HTs just swung wild, and the cap, which is rated for 500 volts, had over 700 volts on it. That cap shorted, which then created a dead short on the 3.3K dropping resistor coming from the HT supply. So that resistor burned, the cap exploded, it smelled bad, looked real bad. You can still see I've got a little bit of a patch, just some red nail polish to cover the carbonized area, which is no longer in service on this board. And a new 5-watt 3.3K resistor instead of the old burnt 2-watt. That then goes to this new diode and then goes over here, well away from the heat, to the new bias components. So the filter cap for that is here. It's a really high quality capacitor, and I just changed the layout. Same values that SL amps use, just laid out differently, with this trim pot here, which means that this old trim pot is about to leave, and I will plug that hole so that one can stick their finger inside. The HT fuse that was on the center tap going to ground, that's been disconnected. That's just hardwired to ground. A new HT center tap was installed here. Right now, that is a 1 amp fuse. 500 milliamps would occasionally blow. I think 750 is probably what the math would say. 1 amp is probably close enough. I'll debate whether to saddle the guy with a hard to find fuse value. Relatively hard to find. Because of the nature of this circuit and the low voltage supply and the cathode follower supplying the bias to it, if anything went wrong with one of these output tubes, it could nuke the entire bias supply and cause a lot of problems. So I added these fuse holders, one per output tube, which just fuses the cathode of each tube. Those are 500 milliamp fuses. I'm thinking probably 350, 400 milliamp would be what the math would say. Again, this is probably enough protection at 500 milliamps. It's a value which is easier to find. I bumped up the screen grid resistors from 470 ohm to 1Ks because it's running on the hot side on a screen voltage for a 6L6. I added some flyback diodes to each output side. And the half power switch was physically failing. I replaced it with a Carling which matches the existing power and standby, and redid all that wiring for the half power mode, which I'll test. I also want to test how the half power mode might or might not affect the bias. And one other thing to play around with while I have the amp here is that Dumble often intentionally mismatched, misloaded his amps. He would use an amp with a 4 ohm output transformer, a fixed 4 ohm output transformer, and provide it with an 8 ohm cab. He liked the sound of that. I'm going to play around with it and see if I hear any difference. That's just a matter of using an 8 ohm cab on the 4 ohm tap, or a 16 ohm cab on the 8 ohm cab. And there may be some benefits if using half power to doing that as well. I will experiment with that in the safety of my mad scientist lab, where I've got current limiting and things are less likely to go wrong. This 6L6 here, which had the broken off keyway, seems to be okay, which is really good news right now when 6L6s are hard to come by. So I will glue on a new keyway to that. I've got a part that does that, prolongs tube life. But I'm pleased with all this. This was all stuff that probably should not have been necessary. But when you have a very complicated circuit like this, sometimes you run into that perfect storm problem that many quite good and knowledgeable builders might not have anticipated. I think if I had been sitting down to design an amp that did something like this, I might have anticipated it. But if I was sitting down to design to copy an existing Dumble design, I probably would have said, well, Dumble did it, it's probably fine. You know, everyone's mileage can vary. This one certainly varied in a fiery way, but pending further testing, it seems to be healthier than ever and should last a good long while. I'm a little bit concerned about one or two of these power tubes that had some, put it this way, there's no sign of physical damage, but when that bias supply went before, and then the amp was powered on with a fuse rating higher than the amp should have had, it had a 6 amp fuse instead of the proper 4. It's not good to operate output tubes without a good bias supply. So I'll be keeping an eye on those. But so far, so great. All right, I had already recorded some playing right before I did the changes to the bias circuit here. And for whatever reason, it didn't record right. So I don't want to leave you guys in suspense. Let's hear it a little bit before we stop with this video. We'll get a chance to hear it more properly, later with the reverb tank hooked up, and I'll show what the controls do. This is just a set and forget kind of thing right now. Nothing too crazy. Let's see how close it comes to what people expect this thing to sound like. Good Lord, this thing wants to be bright. Like I said, I'll play around with it more and take all the controls into consideration later. I haven't played that stuff since I was 17, so bear with me. of scared of it. I think we'll stop there for now. The beast is alive. Let me have less rusty hands and a better sense of what the front panel controls do, and we'll give this thing a better playthrough later.